Hello and welcome. I'm Jared. If you're new here, I'm a Rubyist. I run a company called Supergood Software where we build Ruby on Rails based e-commerce software using a platform called Solidus. Today we're doing Advent of Code. We've just finished day 16 and are headed into day 17, which I'm told is a little easier. I already did day 15 earlier today, just trying to catch up over the course of the day. I'll definitely be taking a break if I manage to get through day 17 here before I come back and attempt day 18. And I will not be around this evening for day 19 because I need to play hockey. I'm just going to add remove pry, left pry in the code. Now let's head over to day 17 here. Make sure everything's good over there. Yeah, we're good. Day 17 trick shot. Finally, you decode the elf's message. Hi, the message says. You continue searching for the sleigh keys. Ahead of you is what appears to be a large ocean trench. Could the keys have fallen into it? You'd better send a probe to investigate. The probe launcher on your submarine can fire the probe with any integer velocity in the x, forward, and y upward or downward if negative directions. For example, an initial xy velocity like 0, 10 would fire the probe straight up with an initial velocity, while an initial velocity like 10, negative 1 would fire the probe at a slight downward angle. Okay. The probe's xy position starts at 0, then it will follow some trajectory by moving in steps. On each step, these changes occur in the following order. The probe's x position increases by its x velocity. The probe's y position increases by its y velocity. Due to drag, the probe's x velocity changes by 1 towards the value 0. That is, it decreases by 1 if it is greater than 0. It increases by 1 if it is less than 0. Or it does not change if it is already 0. Due to gravity, the probe's y velocity decreases by 1. For the probe to successfully make it to the trench, the probe must be on some trajectory that causes it to be within a target area after any step. Glad to hear it. The submarine computer has already calculated this target area, your puzzle input. Target area means that you need to find the initial xy velocity values such that after any step, the probe's x position is at least 20 and at most 30, and the probe's y position is at least negative 10 and at most negative 5. Given this target area, one initial velocity that causes the probe to be within the target range after any step is 7.2. In this diagram, S, the probe's initial position, 0, 0, the x-coordinate decreases in the right, blah, 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 so it's going to sort of show us a trajectory. So this shows it passing through without having actually hit it because we move in steps. How high can you make the probe go while still reaching the target area? In the above example, use an initial velocity of 6.9 is the best you can do, causing the probe to reach a maximum y position of 45. Any higher initial y velocity causes the probe to overshoot the target area entirely. Find the initial velocity that causes the probe to reach the highest y position and still eventually be within the target area after any step. What is the highest y position it reaches on this trajectory? Okay. That seems straightforward enough. All right, day 17, part 1. Day 17, part 1 spec here. So that's what our input looks like. Target area. So we have a sample target area here. And I guess the first thing we got to do is just parse that. And then we're going to expect for day 1. This is interesting. Not clear how all of this is going to work, but let's just go in here. Oops, not git commit. What are we doing? RSpec. Oh, I've left a focus somewhere. All right, we're back here. And we can even focus this one. So input, strip any extra stuff, and then we just really want to parse this. So who cares? X equals Y equals I just like eval that. Oh, it's got a comma in it. Get out of here, comma. I can. And does it work for the other one? All right, we're committing crimes against Ruby and evaling our text input. So if you want to hack my computer, the thing you need to do right now is somehow hack Advent of Code right now and replace my input with something that will evaluate malicious code when I do this. Good luck. You have... Oh, you missed your shot. Sorry. These are the ranges. That's probably not a fair thing to call them, but I think that should work. Convenient that they just happen to use the same syntax that Ruby uses for ranges. Okay, got that. Then I want to make a the one thing I don't understand is how I'm going to constrain the problem space, right? Because like, okay, my head's getting itchy here. I can't look through everything. I mean, let's build a probe. Let's build a probe class. I'm going to make a class probe. It's just going to be a struct. It's going to have. I don't like that I used dx there. It's going to have x. It's going to have y. It's going to have vx, velocity x, velocity y. We use keyword in it. And we're going to be able to call step on it. And when we call step, it's going to create a new one that implements whatever logic we want here. is my thinking. That's not right. So I guess we can like write a secondary test here to test that our probe is functioning as intended. Gives us some time to think through how this thing works. So let's unfocus that and just write a separate describe for our probe here. You don't even have to bother with X to maximize Y. The rate at which the probe leaves x-axis is the same as when it comes back. So the max speed implying height can be calculated just by how long the target area is. I have to think about that. I need more coffee today. All right. It moves the way we expect. Going to fix this one. So, probe's position starts at 0, 0. I need to provide all the values. No. Good, but I guess I do need to. So which, what's our test case here? Start. Interesting. I mean, I feel like I'm going the like simulation route rather than the. Maybe I should reread the problem, but for now I'm just going to put this in here. Equals probe.step, and then I'm going to expect probe.x to be something, probe.y to be something, x to be something, and by to be something. So we know, so it should go 1, 2, 3, 4, 5, 6, 7 over and 3 up. So it should be at position 7, position 3, and then we will expect due to drag, the x velocity changes towards 1, by 1 towards the value 0. So the x is going to now go down to 6. The y is going to decrease by 1. We'll do the same thing. So 7 plus 6 is 13. 3 plus 1 is 4. This is now going to be 5. This is now going to be 0. And 13 plus 5 is 18. 4 plus 0 is 4. And let's just take a quick look at, that looks like it accelerates downwards. So these are all equal. So this is going to be x plus vx. This is going to be y plus vy. This is going to be, this is going to be 1, and this is going to be if Vx is greater than 0. It's gonna be a whole if-else condition. If Vx is greater than 0, sure, well, let's just do the basic case. If it is 0, then 0. Else, if Vx is greater than 0, then it's Vx minus 1. Else, if Vx is less than 0, it's going to be Vx plus 1. Typo something. So which assertion is failing? Line 25. Well, that's because I didn't write. I thought that I said 2. Or I thought that I said 3. So just gonna throw our values off. 3 plus 0 is 3. Okay, we have a probe that functions the way we expect a probe to function. So now we can write the code to determine whether a given probe is going to hit our target. That's definitely not the direction we're trying to go. What's our input look like? It's a big number. So let's just play around with this. So we can make it a probe. Probe equals probe new with the x6 and vy of 9, and we always want x0, y0. Don't know that there's a way to do default arguments with the struct. I guess I could give it an initializer, but it doesn't really matter. So we want to do I'm going to use that terminology. So I can create a hit and a miss method. What? Oh, I see. Plus overshot. So we can say until probe hit our x range, y range, these are instance variables. or overshot it. Probe equals probe.step. We're expecting this one to land in, so I'm still not exactly sure how we're gonna like limit the space of what we want to try and simulate down to something that where we can just search it for what we want. But we'll just pry when we get there. Make sure we get there the way we expect. I guess I can just record it as I go. We'll see. We'll figure out the way to do it. And then hit is just X range cover X and Y range cover Y and overshot. I don't know what methods on this thing we actually want to play with. So is it like top or end? Yeah. So we can do like X is greater than X range dot end, or Y is greater than Y range dot end. So we have the probe. It is at X0, Y0. That doesn't seem right. It hasn't gone anywhere. Which one of these erroneously returned true? Really? Without moving, what did I do? X is greater than... Oh, Y is... Let me look at those ranges that we're using as inputs again. I think that works. Okay, that's fine. It's just that this is our start. Or some other method. What method do ranges have? Beginning? Dot begin? Okay, sure, whatever. And we want it. It'll be less than. Okay, we have a probe. It is at position 21, -10, and that could be the answer. I mean, is that within our thing? 29, -10 is within it. Okay, we're gonna just make them keep track of their max heights. That seems fine. So this is just max height y x. or I guess it's the new y that we care about here. So I guess it wouldn't really matter either way, but okay. Now we just got to make sure they get initialized with zeros. I guess I should call it max y. That's probably more sensible. And at the end of this short journey, let's just do one more step and make sure this records correctly. So 18 plus 4 is going to be 22. 3 minus 1 is going to be 2. This is going to decrease to 3. That's going to decrease to 2. And we're going to expect probe max y to equal max y it reached was 3. All right, come on here. Okay, so the ones that are failing are probe moves the way we expect is failing on 50 of this file. Y is 2, y is 3, y is 3 minus y is 2. We are getting a value of 2. Because we, oh boy, this is max y. Okay, we're back in the realm of possibility. And we can kind of just search a space. Let's just pick an arbitrary one. I mean, we know the answer for, we know what works for this one. We can pick 0 to 30 dot each do x, 0 to 30 each do y. We have some loops. We can collect all our hits in here. And then at the end, map them to their max y's and pick the max of them. And here, can do this thing. So we, until we either overshoot, or we can just loop. Loop do, and then we can put some conditionals in here. We just probe equals probe.step. Oh, we should be starting these with, these are vx and vy respectively. Let's not confuse ourselves further. So if the probe hits, we're going to do something. Else, if the probe overshoots, we're going to do something. Otherwise, we're just going to keep going. If probe hit, then we are going to put it in the hits. We are going to break. If the probe overshot, we are just going to break. This could conceivably pass our test. Okay, let's focus the one spec we care about and start getting into this. Oh, we want the, okay, no, we did this wrong. This is max by, and, oh, we need the starting. Okay, we can do that though. So we can just throw the probe away at this point. We can record the max y that this probe hit and the starting velocity, and then after we've done all this, we just take our hits, max by first, still failing. 17. Oh, we're not passing in a max y. Starts at 0. Okay, well, that passes. Not. So if I bin solve this one, it's not even probably going to. So yeah, it's going to produce a solution. Could be right. I've just arbitrarily. It's probably not. Yeah. But that was really relatively fast. We know that the input, we're aiming for somewhere in that space. Like, can we search million? How long is that going to take? Too long? I feel like we should be able to throw the x's away in some way. Well, that was fast enough. Not the answer. Oh, no, never mind. It's just, probably is the answer, but. Also not the answer. Too low. Interesting. What's the best way to do this? How do we restrict the we wouldn't want it to be larger than the X range end. What was that? What's that in our input? I feel like that's going to make it finish relatively quickly by restricting that even smaller. But it's got to be something more clever than what I'm doing, though. I mean, I guess I could search for the x's that end in the area. Because there's going to need to be... no, that doesn't work. I mean, they're independent, but... it needs at least a certain amount of x velocity to get to the beginning. So we can find that number. I wonder how far through this is. I definitely chosen a much too large number there. Okay, those are too big. Those are too big. What do we do here? How do we pick good ranges for this? I mean, we can write like a min x thing. I know that part. All right, because min vx is going to be we can do like a quick simulation. To look for it. And we just have to do like if vx, if don't know how to write a method. We can also restrict the x's even more, right? Because we can pick only ones where it ever falls inside the X range. That significantly limits the problem space. Okay, we'll do that after. So what does can reach look like? If a given value can reach given start, it means that just think through this. If it can reach a given start, then actually YOLO. Let's just do that. It's still a large number, but I wouldn't expect it to be so big. Unless I'm missing a possible VX or something. Next, we don't need a second argument here. So start is going to be begin, being, and, or yeah, let's call it finish, and so until Vx is so if Vx, how are we doing this? Loop, if return true if Vx, or if X range cover, if it covers it, otherwise return false if Vx is 0 or Vx is greater than finish. Vx or actually no, it's x equals 0. This is what I'm doing. This is what I'm doing. Now we go. if vx equals 0 or x is greater than finish. Then x plus equals vx, vx minus equals 1. Okay, error finish is not set. I'll just use it as a literal here or inline here. Oh. So that should reject x or vx candidates. I want to see what's happening here. So we're getting a variety of hits. I am skeptical that 1-1 hits. Or that 0-0 hits. What the hell? Or sorry, no, that's the right. These are max y's and y velocities. I mean, that looks... I mean, it completes in a reasonable amount of time. Because we can reject x values. But even with a massive number, is it because I'm like, are there negative values I need to consider? No, surely not. Why am I getting a wrong number? How am I getting 101 over again? Did I punch it in wrong? Not that your answer is too low. If you're stuck, make sure that use the full input data. There's some general tips on it. Oh, yeah. Everything's passing in my specs. What am I missing, chat? Come on. Help me out. For me, the bottom boundary was -78. So the speed upon touching x-axis would be -77. Which means the starting y would be 77. So the max height right. That's interesting. Okay, I didn't understand that when you said it initially. if you're still here. Bottom boundary -78. I still don't understand how that could, like, that means I could find it more intelligently, but I don't understand why brute forcing it is finding it in the test case and isn't finding it in this case. Oh, you don't even need to bother with extra. Okay, I fully. Brain wasn't there when I read that first time. Well, this is useless then. And I can just, excuse me, I can just, did I do that right? Yeah. Bx to 0, and then instead of using x range, I can just use 1 to 1. But like, that's really slow now, but still finds 101. Which, like, let's come in. Does that make sense in terms of my input? Yeah. How could my answer not be 101? Oh, what's the highest x position? Oh my god, I read the problem wrong this whole time. Chat, come on. I wrote this test wrong. It's supposed to be 45. Yeah, okay, I don't even search that space. I don't even care what this number is. 500, sure, that'll work. Passes. Oh man. All right, brutal. Reading comprehension. Gotta get better at it. All right. The fact that I wrote the spec wrong, I think, is what killed me there. Maybe a fancy trick shot isn't the best idea after all. You only have one probe, so you had better not miss. Yeah. Maybe a fancy trick shot. So to get the best idea of what your options for launching the probe, you need to find every initial velocity that causes the probe to eventually be within the target area after any step. In this example, there are 112 initial velocity values that meet these criteria. How many distinct initial velocity values cause the probe to be within the target area after any step? Okay, can work with that. I understand that. I can write a test against that. This is going to be 112. Let's focus on this. We can use Everhit's range here. Just don't need it for part 1. Cool. Day 17, part 2. So we can do something similar here. We're just going to be counting them though. So we can move this back into X range. We can move that back into X range. I mean, these are unnecessarily broad loops, but we can use our Everhit's range method. I don't actually need to know what they are, but oh, and I need to actually pass in Vx. Take a look at what we're producing, figure out why we could be so far off. We're only getting we can it's begin. I want the absolute value. It's only 23 hits. What's going on? Some of these are negative y velocities. I mean, I guess we can just go from well, oh, Oh, there we go. Did I just... run without saving or something? Okay. Time for a break. Alright, there we go. Well, we were bound to have one of those really bad reading comprehension struggles, and inevitably, that one got to be it. Based on the time now, I'm probably not going to do any more today, but I will be back tomorrow to try and catch up, continue my catch up this weekend. It's been a pleasure. Thanks everyone for coming out. If you're watching this on YouTube, also thanks for watching or whatever. Hope you all enjoyed it. See you tomorrow.